Hi, we have the AP Physics 1 past paper 2015. We are discussing free response question section. Question number 3, that's carry the 12 point and the estimated time is 25 minutes. The block is initially at the position x0, mean it is at that position initially and in contact with the uncompressed spring of the negligible mass. The block pushed back along the frictionless surface from position x0 to x minus t. Mean it is directed that is in that direction, that is minus t point. Okay. Compressing the spring by the amount delta xt, mean that is the displacement delta xt. The block is then released. Again, the block is released. Now the block will move from this position to this position. Okay. The x at x0 block enter the rough part. Mean this is the position where it is indicating that is the rough part and eventually come to rest. Mean at that point the block come to rest at x is equal to 3D. The coefficient of kinetic friction between block and the rough track is the mu, coefficient of friction we provided. Part A is the question. On the axis below, sketch the label of graph following two quantities as a function of position x is equal to minus d to 3d. Okay, you don't need to calculate the value for the vertical axis, but some vertical scale should be used for both quantities. Kinetic energy of the block, potential energy of the block. The given space is this one from 0 to D and 0 to 3D. We have to place the block touches the uncompressed spring at the position x0. So at that in the initial, if when the block is compressed initially to the minus D, it has potential energy. At that moment, kinetic energy is 0. When block is released, the potential energy decreases and kinetic energy increases. At x is equal to 0 position, then it has maximum kinetic energy. At that moment, totally uncompressed spring, so potential energy is 0. After that, the spring is disconnected from the mass is disconnected from the spring, so it doesn't carry any potential energy. But at the it is moving on a rough surface, so kinetic energy is decreasing gradually. At the end, it come to at rest position. Okay, step by this is a graph. We now discussed what happened at x is equal to 0, kinetic energy is 0, potential energy is maximum, block is stationary, so kinetic energy is 0, and fully compressed, so fully potential energy is maximum. At x is equal to minus d to 0, at this position, so what's a frictionless track? Kinetic energy is increasing, kinetic energy is maximum at x is equal to 0, 1 by 2 kd, and potential energy is decreasing. Block move toward x is equal to 0, spring expand and potential energy decreases. So no friction, mechanical energy is conserved, potential energy is converting to kinetic energy. As k increases, u decreases. At x is equal to 0, u is equal to 0, k is equal to maximum, as we have seen in a graph. Okay, next position from x0 to x3d. The rough track, no spring is involved, kinetic energy is decreasing and potential energy is 0 because spring is not involved, potential energy is 0, friction present, so block move loses kinetic energy. As we seen 3D kinetic energy is solely at x is equal to 0, kinetic energy is there. So work done against the friction minus decreasing minus mu n into 3D total distance into force, and that's the equation we can calculate for the rough part kinetic energy. Kinetic energy decreases linearly from x0 to x3d. Slope is constant, so negative force minus mu mg is involved. At x is equal to 3d, kinetic energy is 0, potential energy is 0, block is at rest, and spring is disengaged. Now the new situation arises. Now spring is compressed twice as delta x is equal to 2d initially. The student asked to predict whether the final position of the block will be x is equal to 6d. In previous case, it is 3d. Now, because the spring is twice compressed, it is predicted that the x is equal should be 60. The student reason the spring compressed twice as much as block will have to and more energy leaving the spring, so it slide further track before stopping at x is equal to 60. We have to solve for the 2 points. What aspect of the student reason, if any, are correct? You arrived from your answer. What aspect the student reasoning incorrect? Okay. From compressed spring, we know the block more energy 1 by 2 k delta x square. Initially, in previous case, 1 by 2 kxd because it is compressed to the d. Now it is compressed to 2d. So the energy become 4 times. So from previous case, it is 4u1. Okay. Now, incorrect idea, students think that twice compression, it is twice, slide twice 6d. From 6D to 3 instead of 3D it goes to 6D on a rough surface. This is incorrect because the spring energy doesn't double but it grows from the x square tree, mean it is going to stopping distance on a rough surface depend upon the work done by the friction, which is equal to the kinetic energy at x is equal to 0. So friction work depend linearly on a distance. We know the work done by the friction minus sign is decreasing, mu n is the force and delta is the displacement. So minus mu mg it's delta x. New stopping potential is not 60 but further because it has the more energy as compared to the d. Okay. Part C, use quantitative reason including equation as needed, develop the expression for the new final position for the block. Original case is this one. We have the energy 1 by 2 k d square. New energies for u, as we have seen in previous case, initially work done is by the friction is equal to u1. Now u2 is equal to 4u1, 4 equal to 4 work done by the friction. New work done is equal to 4 times. We place the value delta x2 from delta x2 for the new position, delta x1 that is equal to 3d in initial case. Identical factor should be cancelled. Then we know that delta x is equal to 12d. That is the new distance, the body cover. In D part, the explain how any correct aspect of the student reasoning identified in part B are expressed by your mathematical relation in part C. Explain how your relationship in part C correct any incorrect aspect of the student reasoning identified in part B. Refer the relationship you wrote in part C, not just the final answer you obtain by manipulating those relationships. Correct part of the student, the block will have more energy. It's not exactly he expecting, but it is more energy. Expected the new energy is 4 times the greater, which is completely consistent with the student correct statement. Now, incorrect part, twice the compression, twice the distance, that is equivalent. It's saying 60, but it's actually 12d. The distance doesn't scale linearly with the compression. The student misleading the show quadratic dependence of energy on a compression. Therefore, stopping potential also quadruple. That's the solution of the question. If you have any query, kindly ask in a comment. Okay. Take care.